Hello students, welcome back to the maths digital class. We are going ahead with our subtraction, lesson 1 subtraction. I hope you are keeping well. Do keep well and continue doing the homeworks and the classworks. Today we are going to deal with the cardinal and the ordinal numbers. So what is the meaning of cardinal number? Although you have learned this since your class KG2, but we are going to do this again, and it's a kind of revision. So a cardinal number is the total number of objects or people in a group, and an ordinal number tells the position of an item or person in a group. Like here you can see there are 5 boys standing. 1 2 3 4 5 5 boys are standing, so their number will be 5, but the boy standing here, the last, can be also called as fifth. You can also say that in the class how many rank holders are there. So you can say there are 10 rank holders and your rank goes that way. So the cardinal numbers are, it goes like this: 1 2 3 4 5 6 7 and onwards. But the ordinal numbers, particularly we talk about 1, so that will be first, and particularly when we talk about 2, that will be second. When we talk particularly about 3, that will be called as third. So likewise we call, suppose somebody has got 15th rank, okay, so that person particularly, if it is asked, so that will be 15th. Particularly we are talking about only that 15th person or 15th one. Okay, so this is the ordinal numbers, and these are the cardinal numbers. Okay, so cardinal and ordinal numbers. Let us go ahead. We are also going to learn about odd and even numbers. So according to the even numbers, the numbers which are completely divisible by 2 and they end with 0, 2, 4, 6 or 8. They are completely divisible. It means when you divide these numbers by 2, there will be no remainder. You can see these are the examples here I have given. So when you divide these numbers ending with 2, 4, 6, 8 or 0, so if you divide them by 2, there will be no remainder left over. There will be no remainder. So these are the examples here: 24, 136, 1000. So it is ending with, here it is 0, here it is 6, here it is 4. So they end with 2, 4, 6, 8 and 0. Okay, so the odd numbers are the numbers which are not completely divisible by 2. They are not completely divisible by 2, and they end with 1, 3, 5, 7 or 9. Means other than these numbers, whatever are the digits left over, they are odd. Other than these numbers, okay, other than these are even, and other than these are 1, 3, 5, 7 or 9, and they are called odd. So their examples I have given here: 31, 509, 2011. You can see the last numbers. Now when we divide these numbers by 2, we will see that there will always be a remainder. When we divide these odd numbers, when we divide them by 2, we will always get a remainder. I have shown you here, I have divided and shown you here. That is why it is written that the numbers which are not completely divisible by 2, the odd numbers are the numbers which are not completely divisible by 2. Okay, so I have shown you here. That is why they end with 1, 3, 5, 7 or 9. That is why these odd numbers end with 1, 3, 5, 7 or 9. So I have shown you here 31 by dividing by 2. This also same way, since 9 is not in the table of 2, they will always get a remainder. While these even numbers, you can see this 24. If you know the table of 2, 2 12s are 24. Okay, so again there is no remainder. So that is why it is written that numbers which are completely divisible by 2. It means when we divide these numbers, the even numbers, when we divide them by 2, there will be no remainder. While when we divide these odd numbers by 2, we will always get a remainder. And another easy part is when these even numbers, they end with 0, 2, 4, 6 or 8, and the odd numbers, they end with 1, 3, 5, 7 or 9. Okay, so these are even and odd numbers. Now 9. So before giving the homework, I would like to I would like to deal with some questions of your exercise. This is exercise 1B. So these are few of the questions which you may find little difficult. I'm going to deal with these questions. The 16 says write the difference between the largest 4-digit number and the smallest 4-digit number. Now 17 is also similar. What is the sum of the smallest 4-digit number and the smallest 4-digit number, the largest 3-digit number and the smallest 3-digit number? So this is the way. If although it's very easy, you have to solve it very carefully. Okay, so the question is, I'm going to show here 17th one, the sum of the smallest 4-digit number, the largest 3-digit number and the smallest 3-digit number. So the smallest 4-digit number I have given you that day, the previous class. Smallest 4-digit number is 1000 and the largest 3-digit number, you know this, yes, it is 999. Now smallest 3-digit number, you know that it starts with 1 and the rest of them are zeros. Okay, so the sum is, we just have to add this totally. The sum is 1000 plus 999 plus 100. Okay, this is smallest 4-digit number, the largest 3-digit number and the smallest 3-digit number. Okay, so let us add here, making the column. In this way we will be careful in adding. Then 999, then it is 100. We're just adding it carefully. So 9 plus 0 is 9, 9 plus 1 is 10, 0, carry over 1, it becomes 2. So our answer is 2099. Our answer is 2099. This sign I have given, this sign shows, this sign says therefore. The sign means therefore. Therefore the sum. Okay, this is the meaning of this. This is the instead of therefore. Therefore sum is equal to this. Okay, we use this signs in maths. Now the question number 18 here, you can see what is the product of the place value of 7 in 1278 and the face value of 2 in 5623. Okay, so this is also very easy. You just have to be careful. Now the place value of 7 in 1278. So place value of 7, you can see 7 is in tens place. So 70, 7 tens. Now face value of 2. Face value of 2 anywhere will be 2 only. Okay. The term product means when we multiply two numbers, we get the product. So product means you have to multiply. So this will be 70 into 2. Okay, this will be easy. 7 2s are, 7 2s are 14 and 1 0 is brought here. So our answer is 114. Now the last question here. These two are also same. What is the successor of 1800 plus 6? And what is the predecessor of 5689 plus 1290? So these two are simple questions here. You just have to first solve this or this, and then you have to find whether it is successor or it is predecessor. So I can show you here. So question number 20 says, what is the predecessor of 5689 plus 1290? So for this, first we need to add these two numbers and then we need to find the answer's predecessor. Okay, so first we are going to add here. I written here 5689 plus 1290. So we are going to first add this. This is 5689 plus 1290. So 9 plus 0 is 9. 8 plus 9 is 17. Carry over 1 here. 6 plus 2 is 8 plus 1 is 9. And 5 plus 1 is 6. So this is our answer. So our answer is 6979. This is our answer. So now according to the question, we have to find the predecessor of this number. So we will write, therefore predecessor of 689 plus 1290, that is this number. Okay, is equal to this number together we have got here. So the predecessor means one number before. So what is the number before 9? That is 8. So our answer is 6978. So this is our answer. Okay, this I have just, you can write this number also, but the question says this, so I have written this term only. You can also write the predecessor of 6979. The answer is 6978. Okay children, so let us see the homework for the day. So the homework for today is complete exercise 1B which you have done only till number 15. So you have to complete the exercise of 1B and exercise 1C. Okay children, have a good day. Thank you.